So again, before we get to the calculus, we're going to go and talk about one more problem that deals with equations. This is a tougher one because I need to get rid of the r's and thetas and bring in what they are in terms of x's and y's. So the first thing that I would do is I would multiply both sides by 2 minus cosine theta. So this is going to be 2r minus r cosine theta equals 1. You guys all see that? And then this r cosine theta is just what? X. So we have 2r minus x equals 1. But then there's this, right? So what could I do in order to turn that r into x's and y's? Yeah, so what I would do is I know that r equals the square root of x squared plus y squared. So, right, looking back at what we have here, r is just equal to the square root of x squared plus y squared. So if I use that here, then this becomes 2 root x squared plus y squared minus x equals 1. Now watch, if you wanted to continue this further, you could add x to both sides, so you have 2 root x squared plus y squared equals x plus 1. Let's square both sides now. And so we have 4 times quantity x squared plus y squared equals, and then x plus 1 quantity squared is x squared plus 2x plus 1. And so you could say 4x squared minus x squared minus 2x plus 4y squared equals 1. Do you see what I'm doing by bringing these terms over there? Just the x's. And so I'm left with 3x squared minus 2x plus something plus 4y squared equals 1. Now, what am I doing here with that whole plus something? That's right. So I'm completing the square. Now again, this is like a tougher type of problem dealing with polar equations, but this is what you would do. So you would say, oh, this is just 3 times quantity x squared minus 2/3 x plus something plus 4y squared equals 1. And now let's go ahead and do this. So just looking inside there, remember to complete the square, you take half of that linear term and then square that. So this guy divided by 2 is just 1/3, or sorry, negative 1/3. Negative 1/3 squared is what? 1/9. So what's the value that I just added over here by adding a plus 1/9? 1/3, because it's 3 times that 1/9. So I'm adding a 1/3, so I have to add a 1/3 over on the right hand side as well. Well, I'm thinking to myself that that's going to be 4/3. So I'm adding 1/3 over there. So now this becomes 3 times quantity x minus 1/3 quantity squared plus 4y squared equals 4/3.
Where did you get the x on?
So this inside there, you always take whatever that first term is, the square root of that comes down there. So once you complete the square, so this is going to be something squared. So you take whatever that is, the square root of just that, and then the square root of just that is 1/3, but you don't know whether it's plus or minus. It's dependent on the linear term, whether that was plus or minus. So another way you could say it is, whatever that linear term was that you took half of that linear term that you then squared, that's what goes in there. So then we're going to, let's say, multiply both sides by 3/4. And that gives me that, check out how I'm going to write this. X minus 1/3 squared over something. It's going to be 4/9 plus y squared over something. This is going to be 1/3 equals 1. So why am I doing that? Why am I doing that?
Is that the form of an ellipse or?
That's correct. This is the, when we dealt with conics, which I haven't dealt with conics with you guys, but when you dealt with conics, you know that it's x minus h quantity squared over a squared plus y minus k squared over b squared equals 1. And so that's what we got going on there. But anyway, like I said, this was a more complicated problem. Number 16, let me just look at what Rogowski has.
Wait, so you can just put them on the bottom?
Yeah. I mean, you're not just randomly doing it, but you're doing it so that it can be of the form of what you're looking at.
It looks like sticking out.
I don't even know what chapter this is in Rogowski. Here we are. He has it chapter 12, even though it's chapter 11. This is number 16. He has that the answer is quantity x minus 1/3 squared over 4/9 plus y squared over 1/3 equals 1. And that's exactly what I have. So bam. Okay, cool. So that was a tougher problem. Again, this was in not just with coordinates, not going from one coordinate system to another, but from an equation in polar to an equation in rectangular is what that is. Okay? Okay. Now let's get into the next section, which is all about calculus. Pause.